Hey friends, here is a beautiful Olympiad math challenge. So we are asked to find p when we have 3 to the power of p minus 2 to the power of p equals 65. Let's do this real quick. It's gonna be a bit challenging, but then I'm pretty sure that we're gonna walk through this thing step by step. So I'm gonna be thinking around what we can do about this. So the first that comes in mind, because looking at this, we can't even take the logarithms on both sides. So we just simply do this. I will say 3 to the power of p would be the same thing if I have 2 divided by 2. Because I know 2 divided by 2 give us 1, and then p times 1 will still give us p. So that gives us back this guy. So the same thing I will do to this other one, 2 to the power of p to the power of 2 divided by 2 equals 65. So that's the first approach. What will be the next thing? If I obey this law, product power law, or some people call it power law, when a to the power of n multiplies by n, these powers are to multiply themselves, and we have this one. So that being said, we can as well represent this one to be 3 to the power of p divided by 2, or to the power of 2. Why is it so? Because we can as well have 2 divided by 2, which is this one. This p is the same thing as this. Or alternatively, I can place this p outside, take this 2 inside, which gives us back this one. So the same thing I will do for this other one. The second term, we have 2 to the power of p over 2, all to the power of 2 equals 65. So this gives us a clear vision of what we can do next. I could simply just represent the whole of this with x and the whole of this with y. So I can say I want to keep it simple. Keep in mind, have different ways you can approach this. So I can say let x be equals 3 to the power of p over 2, and I will also say let y be equals 2 to the power of p over 2. So that means wherever I see this, I can replace the whole of this with x, whole of this with y. Let's do that very quick. So we have x squared minus y squared equals 65. Now this gives us what we call difference of two squares. So I'm going to be applying the rule for difference of two squares. What's the rule? If I have, let me just do that real quick. If I have something like this, a squared minus b squared, this is the same thing as saying a plus b into a minus b. Either of them can come first. So that's difference of two squares. Let's apply that real quick. So we have x plus y into x minus y equals 65. And then what are the factors of 65? Think of those numbers that multiplies to give us 65. One of them I can think of is 5 times 13, or 13 times 5, either of them, 13 by 5 or 5 by 13. Either of them gives us that. So I can just have 13 multiplied by 5. Now, if you write 5 by 13, you need to tweak this so that this one comes in first, because if you add up these numbers, it should be greater than this. That's why I'm picking the greater one first, and then the smaller one coming second. But if you change this one, that means you can as well reverse this one. So the bigger number I have, the bigger, the smaller, the smaller. That's the mindset. All right, so that being said, I can apply the product property, or just equating instead of applying the product property. I'll just equate this one for this one, and this one goes for this one. So that way I will have x plus y equals 13, and this should be equation 1. And I will have as well x minus y equals 5. And I'll make this equation 2. This is a pair of simultaneous equation. And to make it faster, I can apply the elimination method. So what do I need to do? I could add, I could subtract. Say maybe I want to eliminate y. That means I have to add equation 1 and equation 2. And if I do that, x plus s gives us 2x. And then y plus negative y will give us 0. So that means this will cancel out. And then 13 plus 5 gives 18. How do we find our x? Divide both sides by 2, which is the coefficient of x. And if this cancels out, you see that your x equals 18 divided by 2. That gives us 9. So if you plug this into any of the equation, x equal to 9 into either equation 1 or equation 2, you can be able to get the value for y. Let's do that real quick. So if I have this value x for here, for this particular x, if I plug this value of x for this particular x, I'll have 9 plus y equals 13. So if I take this to this other side, I'll have y to be equal to that, subtracting 9 from both sides. I have 13 minus 9. Therefore, y gives us 4. Now you can see that x value is 9 and y value is 4. So we want to be sure if these values are correct. This answer, the value for x and y are correct. But before we do that, remember we made a statement over here. X should be represented by this. Y should be substituted for this. So let's take it back. Recall that we had 3 to the power of p over 2 to be equals x. And now we're having our x to be 9. So that means anywhere we see x, we substitute 9. So but the 9 can be reduced to a base so that it has the same base with this one at the left hand side. So we can have 3 to the power of p over 2 equals 3 to the power of 2, which also represents 9. So when the bases are the same, you can equate the power. So p over 2 equals 2. By the time you multiply both sides by 2, so you remove this denominator, you can see that this and this cancels out. Therefore, p equals 4. And this is the value that satisfies that equation. If you do same for y, you can as well get the same answer. Maybe you could just give it a go and let me know in the comment section. If you want to show whether you answer correct, you want to checking for extraneosity. This is the original equation. 3 to the power of p minus 2 to the power of p equals 65. You want to check by the time you plug in p value for this particular p, would the left hand side gives us the right hand side. So let's do that real quick. 3 to the power of 4 minus 2 to the power of 4. Would this give us 65? Okay, what's 3 to the power of 4? 3 to the power of 4 means 3 multiplied by itself 4 times. And that will give you 81. Minus 2 to the power of 4 means 2 multiplied itself 4 times. That gives you 16. 81 minus 16, that will give you 65. So it means p equal to 4 is the solution to the problem. Please don't forget to put the value for x. I think we've solved for put in the value of y into wherever you're having y to see if you can be able to get the same answer. And that's the problem I have for you today. If you found this helpful, please support my page. Do this, and I'll see you in the next one. Bye bye.